So until now, we have discussed about symmetric cryptography. So in symmetric cryptography, we have seen there are two types. We have block cipher and we have stream cipher. Stream cipher, we have seen what it is, and we have seen stream cipher is not normally used. 99% of the time, we are sticking to block ciphers, and block cipher is used to encrypt data. We have seen different modes of operation of block ciphers. We have seen ECB, we have seen CBC, we have seen OFB, we have seen CTR, multiple modes we have seen. And we have also seen what is meant by, we have seen some symmetric key algorithms, and we have also seen what is meant by key derivative function. Now, the next thing is, what are the limitations of symmetric cryptography? That is what we are going to see. So when we started the discussion of symmetric crypto system, we said one thing. We said we have our plain text. The plain text is encrypted using a key, and it is sent to the receiver. The receiver will decrypt the ciphertext using the same key. So the same key that was used for encryption has to be used in decryption, and you will get the plain text. Now we are coming to the practical aspects. So you have a sender and you have a receiver. The sender and the receiver, they can be in the same building, which means they can meet each other and they can share the keys. Or they can be in the same geography. If they are in the same geography, then maybe they will have to manually go to the other location to share the key, or maybe they can send the key in some other secure manner. Maybe send it through somebody who is trusted, or maybe send a mail or something. Now, the next thing is, the two people can be in different geographies. So different geographies means maybe they can be in the same state. Now sharing the key will become difficult. You cannot immediately do that. It will take some time. Now, what if the two people are in different states? What if the two people are in different countries? What if the two people are in different continents? How that key sharing will happen? So when we are talking about symmetric key sharing is an issue. How to securely share the keys is a practical problem that was not addressed in the case of symmetric cryptography. So it is not possible to do real-time communication, real-time encryption for different people sitting in different geographies using the approach of symmetric cryptography, because how the key has to be shared, that was an issue. So the primary problem was key distribution. The secondary problem is, let us assume that somehow we managed to ensure that key is distributed between two people sitting in different locations of the world. Still, even if that issue is solved, we still have the question of scalability. For example, if you have 100 participants, or if you have 100 people in the network, or 100 machines in the network, secure communication of 100 machines need this many number of keys, close to 5,000 keys. If there are 1,000 participants, those participants need around 500,000 keys. Whereas if you look at 10,000 participants, those 10,000 participants, they need this many number of keys. So the number of keys that are involved in symmetric cryptography, as the number of participants increase, is really huge. It grows exponentially. When you have a large number of keys, managing the keys, maintaining the keys, generation of the keys, all these things become really complicated. So that was another issue that was related to symmetric crypto systems. You need a lot of keys. So as the network becomes large, the number of keys becomes unmanageable. And the next thing is, so this is one, this is two. So these two are related to point number two, scalability. And the third point is, when we started with cryptography, we talked about the different services that cryptography gives. Cryptography gives us confidentiality, then it gives us integrity, it gives us authentication, and it also gives us non repudiation. Symmetric cryptography gives us confidentiality. It does not give integrity, it does not give authentication, it does not give non repudiation. For integrity, we have something called hash functions, and we have hash max. But what about authentication and non repudiation? Symmetric cryptography only gives confidentiality, it does not give authentication or non repudiation. So, the drawbacks or the limitations of symmetric cryptography is it does not address the issue of key distribution. Secure key distribution is not addressed by symmetric crypto systems. The scalability is a large issue. The moment your network becomes very large, the number of keys that are required becomes unmanageable. The third thing is symmetric crypto systems do not give us non repudiation or authentication. These two functions are not provided by symmetric crypto systems. So the cryptographic community started working on other alternatives to address these issues, and finally they came up with what is known as asymmetric crypto systems. So asymmetric crypto systems are a type of crypto systems that was developed to address the limitations of symmetric cryptography. So if you look at asymmetric crypto systems, let us see what are the basic concepts, or what are the basic concepts of asymmetric crypto systems. In symmetric cryptography, we are talking about only one key. That key is used for encryption, and the same key is also used for decryption. Whereas in the case of asymmetric crypto systems, we are talking about two keys. There is something called the public key. Public key, as the name suggests, is something that we have to share with others. So public key you have to share, and you have something called private key. Private key is secret. You should not share this. If you share private key, the security of asymmetric cryptography is gone. Whereas public key you have to share, because if you do not share public key, asymmetric crypto system will not work. So you have two keys, public key and private key. Public key you share, and private key you keep it with you. Now the second rule is, in asymmetric crypto systems, you have again encryption and you have decryption. If you encrypt with public key, you decrypt with the private key. If you encrypt with the private key, you decrypt with the public key. So this is the method that you follow in asymmetric crypto systems. Two keys, public key sharing to be shared, private key secret. Encryption with private key, public key means you decrypt with private. You encrypt with private key means you decrypt with public key. Now these are the basic concepts that is involved in asymmetric crypto system. Now next is, we talked about some issues of symmetric crypto systems. Key distribution. Now that is addressed in asymmetric crypto systems. Even if two parties are sitting in any corner of the world, it is possible for them to share the symmetric key without any issue. So for secure key distribution, asymmetric crypto system gives us the solution. There are two approaches for sharing keys. One is called as the Diffie-Hellman algorithm, and the other one is known as public key encryption. So we will see that. So for key distribution, we have solution in asymmetric crypto system. For authentication also, we have solution in asymmetric crypto systems, because in asymmetric cryptography, we can create digital signatures and digital certificates. They can be used for authentication. Non-repudiation also is supported by asymmetric crypto system. Using digital signatures, again, we can obtain non-repudiation. So this table gives some of the commonly used asymmetric crypto systems. Diffie-Hellman is used for key distribution. So whenever we are talking about asymmetric crypto systems can help us with key distribution. It can help us create digital signature, and it can also help us with encryption. So these are three basic functions that are provided by asymmetric. But all algorithms does not support all of these activities. For example, using Diffie-Hellman, you can only do key distribution. The other things cannot be done here. Digital signature cannot be created. Encryption is also not supported. RSA algorithm, using RSA, you can do key distribution, you can create digital signature, you can do encryption. ECC, again, using ECC, you can do three activities. Using LGAML, again, you can do all the three activities. Using DSA, you can only create a digital signature. Other activities are not possible using DSA algorithm. Knapsack, using Knapsack, you can do the three activities. So this table you have to keep in mind. Each algorithm, what it is capable of doing, you have to remember with respect to the exam.